Great.
Okay. Yes. So we had some nice, interesting presentations before, and I'll come back to some of the points mentioned in the presentations before. But so my background is computer science, and in particular security and privacy. So I have usually a very technical perspective on things, and not so much a background in law. But it's interesting to see how the different mindsets. What we see is important. So there are two main challenges that we see. Those main challenges are privacy. Obviously, GDPR is somehow connected to privacy, and we always see attacks. So we see attacks on AI systems, attacks on machine learning, and this may also impact the privacy that people expect of having even if they contribute data that is, for instance, used as training data in AI. So one important thing is that attacks over time only get better. So basically, the situation always gets worse because attacks get better, and you always have to think long term into the future of even if the attacks that you did not anticipate that would be possible. And we've seen this in the past many times. So whenever you release data, or you think that data does not contain personally identifiable information, this might not be true in future if someone finds better attacks. And in particular, if you look at AI systems, it was mentioned in the third presentation by Katarina's, that developers don't really understand, or even the developers don't really understand once a model has been trained how it works. And this is certainly true. One important research direction is obviously explainable AI, but since even the technical people don't in the end understand how everything works, it's much harder to detect attacks, and also much harder to detect unintentional information disclosure, or simply just to quantify this. So if we talk about the privacy aspect, one question that, at least for technical people, comes naturally is how much personal data is actually included in such a model. Can we quantify this? So if then through GDPR regulations, someone might say, please delete my data, and one could argue your data is not really included in the final machine learning model. Obviously, it's not included as a easy to read data set, but somehow it's still included, and quantifying how much of your data is included, or how easy it would be to identify you because you contributed to this model, is at least technically an interesting question. Whether it does have a real world impact on legal cases, I don't know, but technically it's a nice question. So if we look at AI, there are different high-level definitions, such as we build systems that think like humans, so that the process of thinking is somewhat similar to how humans think, or simply they act like humans, no matter how the internal processes work, as long as it looks like a human is acting, that could also be considered AI. Or what we usually see in machine learning algorithms classifications is that we think that those systems behave or act rationally, which obviously humans in many cases don't. So there are two ways of seeing this. And one of them, you can implement AI systems in different ways. You can have rule-based systems, but today, obviously, machine learning and one specific sub-area of machine learning, deep learning, is currently obviously the hype algorithms that we talk about in computer science. Generally, there are supervised learning and unsupervised learning approaches where you have samples with kind of the correct answer, for instance, a classification answer, or unsupervised learning, where you basically just automatically find some clusters. So that's a very high-level overview of what machine learning does. And now if we kind of try to have the context to GDPR, we talk about you're usually not allowed to use PII unless there's some exceptions. all of the audience with a legal background have much more knowledge about this than we do. But one interesting question is then, is data that is being used in a model to create a model, and once you have this model, or once you create synthetic data with a model, also a very modern approach, is this still PII, and can be quantified? How much personal identifiable information is there actually? There's no answer to this, but this is ongoing research. So this is a question: how much PI is actually contained in machine learning models? And obviously, one could say, well, this is transformed. You use original data, and then you build a model, and then from this model you create synthetic data. And this synthetic data is, as the name suggests, not real data. So there's no information pertaining to individuals contained anymore. But this is, as I said, this is hard because if the set of your input data is too small, then obviously there's a lot of intuitively there's a lot of information about one individual included. As the size grows, the influence of one individual shrinks, but then maybe if it's an outlier case that is somehow important and thus receives in the training phase more weight, intuitively again, this information would be, more of this person would be included in the final thing. And and we've seen in the past that when data that was presumed to not contain personally identifiable information, this was simply wrong. I mean, the best known case, and Latanya Sweeney basically built her career, and she's now she's been professor at very good universities in the US for quite some time. She basically built her PhD and her entire career on that. It was almost 25 years ago. She used quasi-identifiers that were thought to be anonymous enough that data could be published. So the medical data with the zip code, birth date, and sex was published. As I said, it's 25 years ago. Today, everyone knows this. This is an introductory example of every privacy, computer science privacy textbook. And those quasi-identifiers, if you put it together with other information, can identify people. Other big information disclosures from information that were thought to be anonymous is at America Online. Some of you might actually still remember this. It was in 2006. The research department released data search queries of more than 500,000 users over a 3-month period, and they obviously removed the direct information about the individuals who performed those searches, but they allowed to link different searches together. And as always, attacks get better over time. So people use this data set, and if they said it's an anonymous data, you can't identify the users. Obviously, researchers try to identify people, and they were able to identify a couple of individuals from this data set. And this research head who published this data lost his job. Yeah? Another example is the Netflix, again published. It was in 2009. What it thought to be anonymous data on about 500,000 customers' ratings on about 20,000 movies was published. And the idea was to have a competition to improve the recommendation system. So they said the researchers who, with this test data, can improve our Netflix, our recommendation system, they'll get $1 million. And obviously what researchers, at least those with a security background, always tries to attack the system. And if someone says this is anonymous data, well, then let's try to find out if we can identify people. Again, what people did is use another data source. In this case, it was an incomplete data source that did not contain as many, not all the ratings that were contained in the Netflix data, but that were made public. It was on IMDb. And the idea was that people rate movies similarly, both on Netflix and IMDb. So if I give two ratings of the same movie, they're probably quite similar. So I'm not a kind of person that lies to one of those sources. So putting those data sets together, again, many people could be identified. So what was thought to be anonymous data was not anonymous, and this was without just input data from basically machine learning processes to improve recommendation systems. So whenever you publish data and you think it's anonymous, it's probably not. And this is this huge incentive problem that people who publish data, in many cases, don't get real rewards for publishing this data. So that's why there's an inherent incentive not to publish data for research purposes. At least in computer security, we deal with this problem. So if we look at machine learning and with a background in security, we always try to break systems. So whatever system we talk about, in this case, it would be machine learning. We try to find some attacks on it, and then there are different phases. The feature selection phase, so which variables or features do we think are important for a model? So which of the features from the original data do we use? Which learning model do we use? Then there's the training phase, and then there's the phase where we actually use the machine learning, usually to do some prediction. And in all those phases, you can try to attack the system and basically systematically finding ways to break a system and to, for instance, disclose personal information is what people in information security do. So what are the attack classes that we have in machine learning? So that's we can try to influence things. So we can, if we have control over the training data, we can insert certain additional or modify existing training data so that the system then behaves differently, so that certain classifications later on won't work properly, or that we know certain attack patterns once we present them to the model, that it will behave in a way that we want it to behave, and that the people who own the system don't expect it to behave. Or we can try to find input data when it's used the system, not during the training, that again behaves in a different way. So famous examples are small modifications on traffic signs. So putting a couple of stickers on a stop sign, and then the machine learning model that recognizes the traffic signs, for instance, thinks it's not a stop sign, but classifies it as a speed limit, something that humans would never misclassify. And again, the reason is that we do not understand that once the model has been learned, we don't understand how it works, and therefore this explainable AI approach would actually solve such a problem. Security violations, so we can try to create false negatives that violates then the integrity of the system, or we can basically try to flood the system with many false positives. So we create samples that are classified as positives and are false positives, and then you get too many alerts or too many cases where you have to actually manually do something. So this is an attack on availability. And in terms of privacy, you can try to obtain information about the original data set. So you can put in specific samples and try to learn and see, and research can work on quantifying how much can you learn of the original data by specifically asking the network questions. And then again, if we go back to GDPR and some of the rights that a data subject has is, for instance, the right to say, well, this data is incorrect, please correct it, or please delete my data. And getting this data kind of out of a learned model, or saying, well, your data is not really included, that's just a minimally included, and we can actually quantify this, would be a nice thing. So research projects that work on trying to improve the privacy in terms of machine learning is, for instance, one EU project, Feature Cloud, So here the idea is that different hospitals or universities have patient data, and that this central feature cloud organization uses this data without obtaining the data, basically training the models locally at the universities, and then having one large model that others, without having full access to the models, so other companies, hospitals, then can access these models and run them, use them as they would like to, but not having the entire model. But even this feature cloud central place that has this entire model never has the individual data. So things, architecture, design concepts that are used there as privacy per architecture and privacy design. And so basically the idea is that you have those raw data hospitals that contribute not the data, but that the models are learned locally and for each hospital, and then you combine those models without having access to the data, and then you have the same model or a very similar model to what you would have if you would have had all data and trained the model with all data. This obviously seems like a good idea for privacy. And again, open research questions are here. How different is this central model? Can you quantify the impact of individual hospitals, how much they contributed, and even in more detail, how much an individual data point contributed to the model? Another interesting research direction is creating synthetic data. So once we have a model, we can create individual data sets, data points that are realistic and that fit to the model, but that are not actual patients. And the idea is, well, if we generate the synthetic data, it's not a real person, so we don't have any GDPR issues. But somehow it's also what is in the second talk Gauthier said, the kind of creating new data in this output. You had the slide where on the output side he talked about creating new data. But again, here it's hard, or from an attacker perspective, we would like to know, if we want to defend against this, we'd like to know how to quantify how similar a synthetic data point is to an actual data point, or if we can learn about something about individuals here. And the obviously ongoing research, and something that everyone in AI is talking about, is explainable AI. And once we understand how a model works, it will address many issues, such as biases will be made explicit, because if there's an explanation and we see that, we can then directly see that this is a bias that we don't want to have, or that we have to be careful about. But in terms of security and attacking systems and getting personal data out of what seems to be a system or a data set that does not contain personal data, but indeed it does, also explainability will potentially help. So once those things improve, we think things should be better. Be happy to answer any questions that you have. And whenever you're interested in security, attacking a system, attacking machine learning, just let me know. We're happy to do many research projects in this area.
Great, thank you so much, Professor Weippl. That was a really insightful kind of technical perspective. Really great.